All right, so this is week 15, set 1, SWYK 3. I know we don't normally do this, but I thought I would try it, see if it works. Use synthetic division to divide x cubed, all that, blah, 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 by x plus 8. All right, so synthetic division, use a result to find all the zeros. So x plus 8 gives me an x value, or a 0, of negative 8, right? You set it equal to 0 and solve all that good stuff. And then we go through the process of the synthetic division. We drop down the 1, multiply, add, multiply, add, multiply, add. We get the 0 at the end. Ding, ding, ding. For the remainder, leaving us x squared plus 4x minus 5. And then I could break it up even further. Well, so obviously that one gives me negative 5. That's a weird looking 5. And a positive 1. So I had negative 8, negative 5, positive 1, which is choice B. Moving up. Question 13 starts out with, slide myself over here. Question 13 starts out by asking for all usually the rational root theorem. Well, we remember that we take all the factors of the constant in the numerator. Well, that would be 1, 5, 11, and 55, and you have to use the pluses and the minuses because you don't know if you're talking about positive numbers or negative numbers, over all the factors of the leading coefficient, which there's only one, plus and minus 1. Well, if I take each one of these things and I divide by plus and minus 1, well, it's not going to be that hard. Now, you see that I wrote plus minus 1, plus minus 5, plus minus 11, plus minus 55. If I were the one collecting the answers, I would take it like that. But I'm going to guess that Math Excel is going to be difficult and wants to make you write it all out like this. So be careful. On 11 or on 13b, it says use synthetic division to test the possible rational zeros. Now, you notice that I didn't do that. I could have. I could have used synthetic division, but when I was looking at this question, I thought, well, wait a second. Look, this would be a good place to use my grouping technique. So out of the first two, I pulled out an x squared, and out of the second two, I pulled out a negative 5. That left me with x plus 11, and that goes with, and then I saw, oh, I could take out of this one and out of this one. They both have an x plus 11, so I pulled that out, leaving me x squared minus 5. Now, so the nice solution there was negative 11. Now, why did I go that way instead of actually doing synthetic division? Well, I didn't want to, there's like, 8 different numbers I had to do synthetic division with? I didn't want to do 8. I don't know, I got lazy. I didn't really want to do it with 8 different numbers. So I was trying to look for a different way. Now, could I have done it with 8 different numbers? I could have even used the remainder theorem where I take the numbers and plug them into the equation. So I could have, on my calculator, plugged in 1, plugged in negative 1, plugged in 5, plugged in negative 5, plugged in 11. But it wouldn't have been till negative 11 that I would have actually seen a 0 show up on the remainder. So that's kind of why I looked for a different way to handle it. But you could still do it that way. And so if I plug in, so now that I factored out the x plus 11, that leaves me with x squared minus 5. I can set that equal to 0 and then start to solve, right? Add the 5 to the other side. There wasn't a linear term, so I don't have to use the quadratic formula. Take the square root. So I get plus and minus radical 5, but you know that Math Excel is kind of picky about how it wants you to write them, so it's going to ask you to the solution set. Now look at this. This is asking me differently. One of the other questions were asking me the other zeros are. Well, this one's asking me for the entire solution set. So please make sure that you write them all down, okay? Not just the 2 irrational ones, because you already wrote down negative 11 in the first blank. I understand why that's a little confusing. All right, let's go to the next question here. 14. I think this is our last one for this particular SWYK. So they give me a graph. They call it an incomplete graph because it's not the whole thing. Find all the zeros. And so I can easily see that negative 5 is a 0. All right, so I'm going to use it in my synthetic division. And you'll notice that my coefficients were negative 1, negative 2, 13, and negative 10. carry down the negative 1, multiply, add, and I got this thing right here. Now, you and I both know that that's negative x squared plus 3x minus 2. But then you're going to notice something that I did. I decided to pull out a negative 1. Now, why did I do that? Well, I pulled it out so that I didn't have a negative in front of the squared term. And then I could do my factoring how I normally do, right? What multiplies together to give me 2. But adds up to negative 3, so I had x minus 2, x minus 1. And setting those equal to 0, I could easily see that the remaining solutions would be 2 from this and 1 from this. And so I got my solution set. Now, choosing the correct graph. Oops, my face is in the way. Choosing the correct graph. Well, look at that leading term. That leading term is negative x cubed. Well, so the right-hand behavior, I see a negative for your leading coefficient, so the right-hand behavior would have to be down. Whoa, what happened there? Pause. Sorry, things got a little crazy there. So the right-hand behavior has to be down. Well, that immediately got rid of A and B. The odd degree, right? Odd degree is telling me that the left has to be opposite of the right. So now we know that the left has to be up. Well, that makes sense. C and D, that doesn't rule anything out. But then I look at the negative 5, positive 1, positive 2, and that only happens right here at choice C. And that's enough for SWYK 3. And we'll see you in set 2.